Welcome to The Explainer. Today, we are popping the hood on modern artificial intelligence to see how it really works. We'll be pulling insights directly from the comprehensive guide AI Empowered, getting into the real nuts and bolts of core AI technologies, how they learn, and the massive ecosystems keeping them running. If you've ever typed a prompt into a chatbot and thought, what is actually happening right now? Well, you're in exactly the right place. Okay, so let's start with the million-dollar question. How does AI actually think? We're going to cut through the dense jargon and break this down into the concrete building blocks that power the tools we use every single day. We constantly hear words like algorithms, models, and machine learning thrown around, right? But how do they actually connect to create something that seems to, think?
Here is our roadmap for this explainer. First, core AI building blocks. Second, how machine learning works. Third, language models and tokens. Fourth, multimodal AI systems. Fifth, reasoning and problem solving. And finally, number 6, the AI ecosystem.
All right, let's jump straight into part 1, core AI building blocks, data, algorithms, and models. To really get AI, you just need to understand a very basic recipe. Think of data as your raw ingredients. We're talking millions of images, text documents, audio clips, the whole shebang. Now, if data is the ingredients, the algorithm is your specific recipe. It's a set of rules that sifts through that massive ocean of information and finds the hidden patterns. It is literally the mathematical engine driving the entire learning process. And then we have the model. If we stick with our baking analogy, the model is the baked cake. It's the final trained system you actually interact with. When you ask an AI chatbot a question, you're not talking to the raw data or the algorithm directly, you're talking to the trained model that has already done the heavy lifting and learned from all that information. So when you map out the entire pipeline, it's pretty clear. An AI starts by gathering data and applying algorithms during the training phase. Then, it moves on to generating probability-driven responses during what's called the inference phase. And here's the kicker. The AI doesn't have human consciousness or true understanding. It's just predicting the most highly probable output based on the statistical relationships it learned while it was training. It's math, not magic. Moving right along to section 2, how machine learning works. Learning patterns from data. Machine learning is the absolute foundation here. It's what allows computers to improve over time without some programmer writing fixed rules for every single possible scenario. And this learning generally splits into 3 distinct paths, all depending entirely on how the system gets its feedback. The contrast between these 3 methods is actually super elegant. First, you have supervised learning. This acts kind of like a teacher providing the correct answers. It uses clearly labeled data to predict known outcomes, like figuring out if an email is spam or not. Unsupervised learning, on the other hand, is more like an explorer. It takes a big pile of completely unlabeled data and discovers hidden groupings all on its own, like segmenting customers based on shopping habits. And finally, reinforcement learning. This one learns purely through interaction. It's all trial, error, and a system of rewards and penalties to maximize an outcome. That is exactly how we train AI to play complex video games or operate robotics. Next up, section 3, language models and tokens, processing human language. Okay, so there are 2 main heavyweight categories of language models. You've got large language models, or LLMs. These are massive. We're talking billions to trillions of parameters. They require huge cloud servers to give you that deep, generalized reasoning. But then you have small language models, or SLMs. These are emerging as a real game changer. They use a fraction of the parameters, millions to low billions, so they're speedy, cheap, and private. You can run them right on your local laptop or smartphone for specific tasks, completely offline. Now you literally hear the acronym GPT everywhere, right? But what does it actually stand for? Well, generative means it actively creates brand new text, code, or ideas. It's not just retrieving a file from a database. Pre-trained means it already studied massive data sets long before you ever typed a prompt. And transformer, this is the secret sauce. It is a deep neural network architecture that uses something called self-attention to understand the context of words across an entire document rather than just reading them in a strict sequence. But here's something you might not know. AI doesn't actually read words the way we do. It reads what are called tokens. On average, a single token is about 3 to 4 characters of English text. It's the absolute smallest unit of text the AI processes. Even a simple comma or an exclamation point counts as a token. And understanding tokens is absolutely crucial because they dictate your context window. Think of the context window as the AI's short-term memory limit for your specific chat. It includes both the prompt you type in and the response the AI gives back. If you hit that token limit, the AI literally starts to truncate or forget the earlier parts of your conversation. So managing your tokens means managing your memory, your costs, and the overall quality of the output. Okay, Section 4, Multimodal AI Systems, Processing Multiple Data Types. We are moving way beyond just text now. AI is starting to perceive the world a lot more like we do. Older AI was strictly single modality. A text model just did text, an image model just did images. But modern multimodal systems are totally different. They can seamlessly ingest text, sight, and sound all at the exact same time into a shared space. That means you can show it a graph, talk to it using your voice, and have it spit out a written report and a video simultaneously. Which brings us to Section 5, Reasoning and Problem Solving, Thinking Step by Step. Traditional generative AI models basically operate like ultra-advanced autocorrect, predicting the next most likely word. But the newest advanced reasoning models do something incredible. They introduce an internal analytical process. Instead of just blurting out the first probable answer, they pause. They analyze the problem, apply step-by-step reasoning, and double-check their own logic before giving you a result. We call this technique chain of thought reasoning. By forcing the AI to internally think step by step, it interprets your prompt, explores a few different approaches, and evaluates the intermediate results before speaking. Honestly, it drastically reduces silly logical errors, and it's quickly becoming the bedrock for complex tasks in math, science, and major strategic decision-making. And lastly, Section 6, the AI ecosystem, the engines powering the future. Absolutely none of this exists in a vacuum. This whole technological revolution is being carried on the shoulders of two main groups. First, the foundation model leaders, organizations like OpenAI, Google, Anthropic, Meta, and xAI. They're the ones actively researching and training the models. But they couldn't do any of it without the infrastructure giants. I'm talking about NVIDIA supplying the specialized hardware chips, along with Microsoft Azure, AWS, and Google Cloud, providing the massive data centers and raw computing power you need to run trillions of parameters. So, we've explored the raw data, the algorithms, multimodal systems, and these mind-blowing new reasoning models. But as AI shifts from just predicting words to actually acting as an autonomous agent with complex, step-by-step logic, it leaves us with an incredibly exciting puzzle. As these systems get smarter, what unique role will human intelligence, creativity, and judgment play alongside them? Think about that for a second. Thank you so much for joining me on this journey into the core of AI today on This Explainer. Keep learning, keep questioning, and I'll see you next time.